let's try performing an actual probability experiment. In this probability experiment, we are going to look at flipping a coin. And I am going to want you to try this at home. So if you can find a coin to use in a few minutes when you try this independently, that's great. If for some reason you do not have access to a coin, you can really use anything that you can flip. You can find like a lid and just decide that one side is head and one side is tails. You could find like a smooth rock. You could find a book that you can flip and toss onto your bed. Really, anything that you're able to flip is fine. A coin is just what we traditionally use, but if you don't have one handy, that's totally fine. Just find something at home, look in your blue box, whatever, something you can flip. Before we perform our actual experiment, I would like us to consider the theoretical probability of our outcome. And in this case, we're going to look for the outcome, or what is the probability of getting tails. So let's use our notation. We're going to do our theoretical first. And we're going to look for the probability of getting tails. Now remember, at its most fundamental, at its most basic, probability is just number of favorable outcomes over number of possible outcomes. So no matter what happens, as we discuss probability, if you feel yourself getting confused or I don't remember how to do the calculation, just take a step back and remember it's just a fraction or a ratio of favorable outcomes over possible outcomes, or favorable outcomes over number of trials that we performed. Well, we're doing theoretical, so we don't have any actual data that we've collected yet. We're just thinking about what we know about the situation. I know that a coin has two sides, heads and tails. So how many possible outcomes are we going to have? What is our bottom number? Well, it's going to be 2. And of those sides, how many are tails? Well, only 1. So my theoretical probability is going to be 1 over 2, and let's practice converting as well. So 1 over 2, which is 0.50 as a decimal, or 50%. And let's just write that using a concluding statement just to have it directly stated. Therefore, theoretical probability of flipping a coin and getting tails is 1 out of 2, or 50%. All right, that's great. Let's actually perform our experiment now and see if we get the same value. And remember, we might not get the same value, and that's okay, because of statistical fluctuation, because of real life circumstances, and especially because we're only performing a few trials. It is not a problem if our experimental probability and our theoretical do not match. So we're looking at the probability of getting tails, and in general we're going to see the number of favorable outcomes, so the number of times we see tails, over our number of possible outcomes, or our number of trials performed. So we'll just say number of trials. Just to be clear, because I kind of used two words that look very similar, let's be clear. So number of trials, or sorry, number of tails goes on top. How many times do we get tails? Over number of trials, how many times did we flip the coin? All right, and we're going to make a frequency distribution table or a probability distribution chart. I kind of use the words interchangeably and sometimes kind of confuse them because they're basically the same thing. So we're going to have our outcomes. Whoops. So our random variable x. Actually, we won't even worry about that. We'll just describe outcome as... actually, no, we'll describe it this way. So our outcome will be our random variable x, which will be how many tails did we get when we flip the coin. So we're either going to have 0 tails or 1 tail. So either heads or tails. We're going to have our frequency. How many times did I get that outcome? And then we'll find our probability. And I'm actually going to add one other part here. So remember, we said that as we go, as we perform an experiment or as we count something, it's often helpful to have a tally chart, or we can quickly make our tally marks and record our results before we actually write it as a number. Otherwise, we end up like scratching out and rewriting our number over and over. So let's avoid that. And so we're kind of combining multiple things here. This is a tally chart because it has the tallies. This is a frequency distribution table because it has the frequency. And it's a probability distribution because it shows our probabilities. So we're doing everything in one compact little table here. All right, so let's go ahead and perform our actual experiment. Rather than flipping the coin, I will be spinning it. I just have it on a plate so we can observe it and see our results. And I'll probably only do 10 trials just for the sake of time. When you do this at home, I think I have you doing more just to get some better results. But let's go ahead and try this out. All right, and our first roll is tails. So how many tails did we get? We got one. Oops. This is going to take a minute. That's okay, though. I do want to demonstrate this. Let's try again. All right, and heads. So how many tails did we get? 0. Try again. And heads once again. And heads once again. And heads once again. And you'll notice that our frequency of having heads is much higher than our frequency of having tails right now. But that's okay. That's just the nature of measuring probability and measuring the outcome of random events. It will probably even out by the end of our trial. Even though we're only doing 10, it'll probably get pretty close. Or maybe all the rest of our flips are still going to be heads. And that's okay, because it doesn't matter if we get the result we expect. We just want to perform the experiment and honestly report what we're seeing. Heads once again. 6 trials. We have 4 more left. Put a little more spin on it this time. Heads once again. It's getting spooky. And heads once again. All right, there we go. It is possible to still get tails. And one final flip, because we're only doing 10. Also tails. All right, we have completed the tally chart portion. Let's move on to our frequency. So remember, frequency is just how often something happened. So how often did we have 0 tails? How often did we have heads? Well, that happened 7 times. How many times was there tails? That happened 3 times. And our total, which we can just state here, was 10 trials. So I'm going to find my probability of tails. And that's going to be how many times we had tails over our total number of trials, which is 10. While we're at it, we might as well find the probability of having heads, which is also going to be out of 10. And what number goes on top? Well, the top number is our number of favorable outcomes. So first of all, we want to find the probability of tails. So how many times was there tails? Well, it happened 3 times. So our probability is 3 out of 10, or 30%. Our probability of heads was 7 out of 10, or 70%. And we can put that in our table here to complete it. And also, as a quick sanity check, anytime we do a table like this, we want our probabilities to add up to 100, because every trial we performed had an outcome. So if we add up the probability of all our outcomes, it has to equal 100%. We can't have any that are missing, or I can't have over 100% results. Like I can't have 10 trials and somehow have 11 results. So if we add these up, 70 plus 30 is 100%. That's just a quick sanity check to kind of make sure that we did things properly. And now my cat is on my desk. Hey, get out of here. All right, so we performed our experiment. We have our theoretical probability of flipping a coin and getting tails, and we found that that was 50%. we have our experimental probability of getting tails, and we saw that it was 30%. And so a question like this might also ask us to compare. So let's say, therefore, the experimental or the theoretical probability of tails is 50%, but our experimental probability of tails was only 30%. This difference is due to statistical fluctuation and I'm just going to use short forms for the sake of time here. And our experimental probability would approach our theoretical probability, would likely approach, if we performed more trials. All right, so this is how to do this by hand. I would also like to show how we can record this stuff using Google Sheets. So I'm going to switch the view and let's try recording these same events, these same numbers in Google Sheets. All right, so let's take a look at Google Sheets, and I'm using a template here, similar to the one you'll be using when you perform your experiment at home. So I have the our handwritten results displayed here as well, so I can kind of copy them over as I work. So let's take a look at our template and let's try using it. Now I haven't taught you too much about using formulas in Sheets, so it's up to you how you want to use this exactly. Basically, just make sure your results are recorded in Sheets so we can take a look at it. So first of all, we want to answer the question, what is the theoretical probability of flipping and getting tails, or whatever it is you're measuring? So if you're flipping a lid, what are the odds of flipping your peanut butter lid and the logo's on the top, or whatever it is you are able to measure at home. And in our case, we saw that our theoretical probability was 50%. So let's type that in. All right, and then I have my tally chart. And here I'm just going to make marks to indicate my tally marks. So how many times when I flipped, how many times was there heads? 7 times. So I just used the letter I. It's a little awkward. I just want to practice the idea of tally charts, but spreadsheets aren't really designed for tallying, but that's okay. So let's have 1, 2, 3, 4, 5, 6, 7. And tails occurred 1, 2, 3 times. Frequency, we're just going to type in the number. So how many times did I see heads as my outcome of my event? 7. Tails occurred 3 times. And then I have a formula set up here to automatically calculate this. So experimental probability is number of tails over number of spins. I have this set up to grab my top number, which is my number of tails, and my bottom number, which was my total number of trials. So 7 plus 3 is 10. And then it finds the probability for me, which is 30%. And then in the written portion here, I want to compare and contrast the theoretical and experimental probabilities. And then I would just describe what I described down here already. So I would say, theoretical was 50%, but experimental was 30%. This is okay. It is due to statistical fluctuation. If we performed more trials, it is likely that the experimental value would approach the theoretical, or something to that effect. So don't copy this word for word. When you do this at home, please use your own words and your own numbers. If you get the exact same numbers as me, then I want you to redo this. In fact, I'm going to say that when you do this at home, you need to do at least 25 trials. So there's no way you will have the exact same numbers as me because I only did 10 trials. So please do not just copy and paste this. Please put in your own measurements.